Welcome back to the channel. In today's video, we will be discussing how to calculate the shear force and the base moment of a tall building that is subjected to a wind load, if the sideways sway is only prevented by the concrete core. Also, we will cover how to calculate the deflection, if the concrete core's Young's modulus is 35,000 Newton per square millimeter, and compare it to the deflection, if the columns and core are connected by outrigger trusses, ensuring that they act compositely to resist sideways sway forces. Finally, if the maximum allowable wind-induced sway is height over 500, we will determine whether the building satisfies the serviceability limit state condition for sideways movement. So, we have the wind load of 1.5 kilonewtons per square meter is applied to the 60 meters wide, 300 meters high tower, which is made up of 16 perimeter concrete columns, 0.45 meters by 0.45 meters, and a 30 meters square concrete core, 0.3 meters thick. First, let's work out the maximum shear and the base moment. The ultimate wind load equals partial safety factor 1.5 times 1.5 kilonewtons per square meter times 60 meters, resulting in 135 kilonewtons per meter of height. The central concrete core works as a cantilever, extending from the substructure to prevent sideways sway. So, working out the base shear, which equals 135 kilonewtons per meter, multiplied by the building height 300 meters, giving us 40,500 kilonewtons. The base moment would be 135 times 300 meters squared, divided by 2. This gives a value of 60.75 times 10 to the power of 5 kilonewton meter. Next, to work out the deflection, we will be using the equation for a cantilever supporting a uniformly distributed load. We already have most of the information. W is 1.5 kilonewtons per square meter, times 60 meters, which is 90 kilonewtons per meter. L is the building height 300 meters. E is Young's modulus 35 kilonewtons per square millimeter. I is the second moment of area of the central concrete core, is calculated in the same way as that of a hollow rectangular cross-section. 30 meters, times 30 meters to 3, divided by 12, minus, open bracket, 30 meters, minus, 2 times wall thickness, 0.3 meters, close bracket, to the power of 4, divided by 12. This gives a value of 5,240 meters to 4. Therefore, the deflection would be 90 kilonewtons per meter, times 300 meters to the power of 4, divided by 8, divided by 35,000, divided by 1,000, divided by 5,240. This gives us a value of 0.5 meters. Next, if outrigger trusses link the 16 perimeter columns to the concrete core. This will stiffen the building, because the outer columns and core will work together to resist sideways sway. The effective second moment of area of the building can be estimated using the parallel axis theorem. The second moment of area of each column equals 0.45 to the power of 4, divided by 12, giving us 0.00342 meters to 4. So, I, for the whole structure, would be 5,240, plus number of columns 16, times 0.00342, plus, open bracket, 10, times 0.45 squared, times, 30 squared, plus 4, times, 0.45 squared, times 15 squared, close bracket. This gives us a value of 7,245 meters to 4. Therefore, the deflection would be 90 kilonewtons per meter, times 300 meters to the power of 4, divided by 8, divided by 35,000, divided by 1,000, divided by 7,245. This gives us a value of 0.36 meters. It should be noted that this approach will underestimate deflections, because it does not account for the stretching and squashing of the members due to tension and compression. Although, the result is good enough for checking the output from a computer-based solution, or for providing a guide to a likely response during the early phase of a design process. We always recommend you compare the results from your analysis software with your handwritten calcs. Moving on. Finally, the maximum allowable deflection is 300 meters divided by 500, which equals 0.6 meters. Therefore, the tower is approximately satisfactory in terms of deflection, both with and without the outrigger truss, which has reduced the deflection from 0.5 to 0.36 meters. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.